So an inquiry-based lesson that we've talked about before, an inquiry-based lesson is when a teacher asks a question. And in the process of grappling with the question, the students learn something. Okay, so that's what I'm doing here. Question number 1. So take a look at these diagrams. All right, and I'm asking you to determine what fraction do you see when you look at these diagrams. First of all, my drawing's not perfect, so assume I broke them into equal pieces. Okay, but what do you see when you look at this diagram? Do you see 1 2/5, or do you see 7/10? Or would we say we can't determine what is shown? Okay, so think about that for a minute. We're going to come back to number 1 and answer that question. And then the question below we'll actually answer a little bit later on. Okay, but the question below that I want you to think about is, suppose this is a quiz that you took. Okay, and so the green is you answering the question, and here's how many points each question is worth. And sometimes teachers will grade this way, right? They'll write the 3/4 here, okay, to signify how many points you got and then how many it's out of. Now, we just discussed the other day that if you add fractions, so if you add 3/4, 2/3, and 3/5, you have to get a common denominator, right? We just learned that in the last clip. However, in this case, when this teacher goes to give you a score, they would add these fractions up like this, right? And then they would say your final score is 8 out of 12. All right, so the question is, and this is where I hate that we lose the talking about things in groups, right? Because you'd be in your groups trying to talk about this, trying to figure this out. But think about, why is it in this case that I can add by adding the numerators and then adding the denominators, right? When we just learned that that's totally not how you add fractions. All right, so think about that as well. And so again, we probably won't answer this until Thursday's videos. But anyway, back up here. Okay, so if we were in class, I would ask everyone to raise their hand. What do you think? 1 2/5? Probably the majority of you would say, yes, I see 1 2/5. All right, the others of you, right, I'm sure there'd be a few people who would say, well, wait a minute. I see 10 pieces and 7 of them are shaded, right? So why can't that be 7/10? Okay, and what I would say to this is that the answer that you should indicate is cannot be determined, all right? Because we could debate it. We could make a case for 1 2/5. We could make a case for 7/10. Here's the problem that occurs with this example. Okay, the problem is I didn't tell you what to consider as the whole. Okay, so fractions are always relative to what's the whole. Okay, it's probably natural for us to assume that 1 pi is 1 whole. All right, and when you make that assumption, then you would answer 1 2/5. Okay, but the answer is C, because I didn't tell you. I did not tell you what to consider as the whole. Okay, so it's natural to say a pi is the whole. All right, but if you looked at a couple word problems over here, if I said Anne baked 2 pies for the bake sale, what fraction of what she baked did she sell? Okay, if I were to consider this word problem and the diagram that I drew on the last page to go with this word problem, then the 2 pies is my whole, right? And then if the 2 pies is my whole, then I would answer here the 7/10. Okay, but if I said, well, the Harris family ordered some pizza, how much pizza was consumed? It would be assumed in this case that 1 pizza is equal to 1 whole. Okay, so 1 pizza equals 1 whole. Okay, if I make that assumption, or if I have that understanding, then the correct answer is 1 2/5. Okay, so it all comes back to what we consider the whole. So in the next clip, we're going to be doing some addition, but we're going to work with different wholes, right, that will determine the value of each of our pieces.